This video is for those of you who have, shall we say, trepidations concerning some of the elements of math in the node editor. It is something I want to address because I do hear of it a lot in emails, on forums, folks who I have worked with. I hear it time and time and time again from artists, that they don't like the math, that they don't get the math, that whatever about the math. And of course, in the broader sense, it's perfectly understandable. The aim of the artist is to do art, not mathematics, for God's sake. We, of course, as computer graphics artists, find ourselves in a bit of a bind this way, however, because the entire world in which we create everything is one big math structure. Every polygon in the space, every pixel in our final render, its shape, its colour, those things are determined at the end of a long series of math processes. Now, of course, our tool is made in such a way that we can just interact with it directly. I can grab and drag my items around here with a mouse or stylus as though I were physically holding them almost. It's natural. We don't need to worry about all of the computations going on in the background that make this stuff happen. But when we build our scenes, it isn't good enough to just be able to grab stuff and wodge it about. We need to be able to move things with precise detail related to other things, and so on and so forth. Texture things in a way that they respond to the light type in just the right way. The first step to that is just getting used to the nomenclature. We are quite used in motion to understanding the idea of axis and the ways in which they conventionally get named, X, Y, Z, the way that their values run into negative or positive territory. We get how the position values of one thing have separation or relation or whatever else to the position values of another, and so on. We get the basic names that are used. So one of the things that Nodal does for us, that we've seen from the introductions, is that it lets us dip behind the background of our scene space here and start pulling out more detailed information and manipulating it in more tightly controlled and ordered ways than just a simple click and drag hands-on approach. And so, like it or loathe the idea of it, it is a tool that is available to the artist. And if you don't learn how to use it, then you are limiting yourself. It's like having a pencil and choosing not to learn how to use the eraser on the back end of it. Now, that's a nice argument and all, and I doubt there's anyone who disagrees with it. Everyone can see the sense in it, but we of course come back to this point. I'm a goddamned artist, not a mathematician. Whether or not the tool is there for me to use, I'm an artist. And here's where the real secret comes out, is that of a fashion, the node editor does not require the artist to do much math at all. What it requires the artist to do is use math. And there is a difference, because using math we are so used to doing. Let's take a peek in our surface editor and just pop open a texture. Now, we're all pretty used to using procedurals, right? I mean, we can look at it and see that we've got different types of noise, for instance, Perlin noise, and we can of course see that that comes from Ken Perlin's noise function, which is long and complex and mathy and not something very nice for an artist. But we don't need to. We don't need to go anywhere near all of that stuff, because what Perlin noise is to the artist is a pattern, a shape. It's like a really complex rubber stamp that he uses to paint things with. And that may seem really simple, but the point is that each of these different types of calculation produce different patterns of noise. If you get to know them by name, then you're able to take reasonably complex math processes and just dump them in. If you do on top just a little bit of background reading about noise shaders and the kinds of ways that they're made, you'll find, of course, that different sets of computations are more or less complex. Perlin noise will render very quickly. It's a very efficient noise algorithm. Lattice convolution can slow your renders down. It's a much more complex method of generating noise and takes longer to compute. I've got a different picture, I've got a different handicap, let's say, in terms of render time, and I've got ideas now about how to use this artistically. And to get deeper into that, I've had to do some background reading on noise shaders and the basic principles and concepts behind the math. But have I had to do or learn or figure out any of it for myself? Nothing. nothing at all. Now that may seem like a lovely and airy-fairy way of viewing the whole thing, and you may think that I'm just trying to make some clever reference to, of course, the ways that we have like procedural nodes in the node editor or whatnot. This is not so. It is invariably when confronted with nodes like these that folks cry foul over such a happy-clappy description of things and getting on with math as an artist. However, this is not true, because all of these things have visual representations. That's what they're doing in a graphics application in the first place. Yes, they have weird names like cross and arccos, the dreaded spot info. But just like noise, you can go through, find the basic concepts of what these things are talking about, whether that be a mathematical function or a piece of data within your 3D scene, and once you have an idea of what they look like, in inverted commas, and you know the names for those different shapes, then when it comes to constructing things in Node Editor, you'll just know which nodes to grab based on the pictures in your head, the same way you do anything else, art-wise. Again, you may think that's great, that'll help you grab a single node, but what about constructing the networks? What about actually building them and putting them together? Well, when it comes to doing that, of course, there is the possibility for invention, the creation of new algorithms, like the noise algorithm there. You could create such a thing in Node Editor from scratch. But that's a very rare thing for an artist to need to do. And what that means is that when you need to construct some kind of technical network, you can go and look stuff up. Essentially turn to a cookbook, if you like. Once you have an understanding of what individual ingredients taste like, you don't need to invent your own recipes. You don't need to understand the recipes that have been discovered by others. You just need to follow the book. And because of our interface, once we've gone on to make our known networks, we can save them and load them for use later. So it's not even the sort of thing that we have to spend loads of time doing all the time. Find a clever function, build it, save it. And once you get into doing that, you come upon a technique of art math I would probably refer to as paint by number, for want of a better name, because essentially that is what you can start doing. You do not need an understanding of how to make stuff from scratch. You do not need to be able to do any of the math. You just need to find the appropriate tool and plug them together in the appropriate way. Obviously, I say you can look stuff up. You won't always find an answer for everything. There are many common little things in node networks, and all you need there is just standard logic. And of course, again, being properly familiar with a lot of the names. And so, what we will do further in this fundamental section, and on occasion when necessary in other parts of the series, is we'll start introducing you to some of just the concepts behind some of the most common math terms and tools, and introduce you to ways to begin picturing those in your head. Of course, there are a great many things we could go into in that sense, many different branches, and we're not of course going to cover them all. We are here to learn the node editor, not mathematics. So as such, I recommend some further reading, and this volume here is a fine choice. All you really need starting this book is the absolute basic knowledge of what shapes are, what angles are, basic arithmetic. If you can do that, you'll be fine. It gives really good, clear, easy to understand explanations of all of the math topics that are relevant to computer graphics. So that's a fantastic place to go looking. Nutex's very own Antti, shader writer, hope I pronounced that right. My Finnish, I'm afraid, sucks immeasurably. He recommends this book, which is more general for mathematics overall, but very nice, short, simple explanations of individual topics. Otherwise, here in this training, we will be looking over a few of the basic concepts and ideas, but only those that are the most common, and of course those that are most relevant to this training and the nodes and topics and projects that we'll be working through. So, we're going to start that out. What I'm going to use, by way of example, for this kind of approach and thinking, is an explanation behind sine, which upsets a lot of artists. I've heard it time and again. Folks just don't get what it means or how it works, or when they might want to use it. The how it works, I think, is usually the important bit for most people. First off, sine is a function. It just modifies a number. We have lots of modifiers that we're used to with numbers that everyone comes across and doesn't have a problem with. For instance, a given number squared. That's easy. You just take a number and multiply it by itself. We're also happy enough with it cubed, if I can turn that into a bit of a dodgy 3. Folks are used to this. It makes nice, clear sense. 3, 1, 2, 3. Even more complex number transforms that involve bits of equations, such as maybe x plus 4 minus 9, and let's say that whole thing divided by 0.2. It's a simple process you can follow to get a number, or use one number, in this case x, a function, which is all of this bit, and create from it a new number. But what is this? What is the method you go through? This is where folks get lost. And here's the reason why. It's because sine does not have any kind of explanation like this. It's not that kind of a process. It's not that kind of a function. It is conceptually very much the same, but practically very different. And here's why I think it's a perfect explanation of this whole way of trying to see things. Because the only way that you can explain sine is not with numbers, nor with words, but with pictures. It is the only way you can describe to someone what it is. And pictures ought be a very natural thing for the artist to understand. So, let's take a look at this picture then. Quite simply, the picture is of a circle, no matter how badly drawn that may happen to be. And in the first way we'll look at it, sine is kind of similar to what we were talking about with radians. It's just another way of enumerating the circle here, except it's slightly unusual, as it goes from 1 to 0 to -1 and back to 0 again. Of course, were this to work the same as degrees or radians or hours and minutes and whatever, then our 0.5 would be here. It would be halfway round. However, that is not how the mapping of the circle works with sine. What sine does instead is to take this central line of the circle here, extend it out, and take the upper edge of it and extend it out, and again of course the lower edge here, and it is then this distance that becomes the 0 to 1 graph range. 0.5 is halfway along it, and of course that coincides to this point on the edge of the circle, and that's why we say that a given angle of so many degrees, sine equals something between 0 and 1, or actually something between 1 and -1 here, because of course angles can come off at this point, where they also have a given negative value or whatnot. What else we can say it is? Well, if we take these numeric values, as we've seen in nodes, and interpret them as colours, then here is 50% grey, and obviously that would start to darken. We'd be getting the 25% here, the 75% black rather. Of course up here would be the 1/4 white. And so of course what we get in this way is this steep, ramped, black to white gradient. So what is sine? Sine is this gradient. It's this particular pattern of shading from white through to black that's weighted somewhat towards the black, more spaced out toward the white, because that shading of course is plotted across the surface of the circle thusly. So we can say that is what sine is. Here's the other thing. If we come back to this graph, if we plot out the degrees of different angles on this axis here, so 0 degrees, 90, 180, somewhere over here 360, and you take each angle, 1 degree, 2 degrees, 3 degrees, etc., and you plot their points and draw a graph through them, you wind up with this smoothed curve graph that lifts off from 0 and steadies out towards 90 degrees. And having done that, if you keep turning through the circle, plotting more and more angles, then it comes back down again in the same pattern by 180 degrees. And then of course it starts to go negative as we come right the way round here, and you wind up with the good old sine wave. So what is sine? It's this shape, always this same shape. Take any figure, sine it, and the result of that will always graph to give you this shape somehow, or to give you this gradient. We should be quite used in computer graphics to crossing over gradients with curves, and how the two are more or less the same thing, just with different visual representations. That's what sine is. It's a representation of a relationship between this square space, as it were, and this curve space. Then of course you've got cosine, which is exactly the same thing, but taken from the opposite side here. So this is cosine 0, and cosine 1, and cosine negative 1, and 0 again. And cosine simply proceeds in that a fashion. But this is why a given angle here that has one position on sine has a different position on cosine, and therefore a different cosine value. And so what are sine and cosine? Well, they're different perspectives. If you think about our angle as a slice of pizza, imagine holding it up in front of yourself as you move it and turn it and change your angle of view. The depth of the arc appears to become shallower or deeper, whether you look at it from this perspective or whether you look at it from the back, that perspective. It appears different, and that's what sine and cosine see as well. They see this perspective. They just spit it out as a number. What else can it be? Well, it can also be perspectives on the triangle instead of just the circle. If we make this a right-angled triangle here, by drawing across from the flat line and up the angle, then the height of this side is the same height as the sine. So that is sine. And of course this top side here, where we're drawing through there, would be the cosine. This length, obviously enough, is equal to that one. So if you've got a triangle with an angle, this is sine, that is cosine for that angle. And so curves, gradients, perspectives, sides and views of things, these should be quite natural and intuitive ideas for the artist. And I'm sure that picking it apart in this fashion, most of you do get it just fine. It's very clear, it's easy to understand, no problem. The problem, of course, comes in asking the question, that's great, but how do I apply it? How do I know when to use this thing? It's not like some shape that I just draw. Much like sine itself, it's kind of hard to explain with words. You've really got to see it in practice. And so when you are going through further tutorials from this series, you will see instances of us using this kind of stuff, functions or constants or whatever else. And whenever we do throw such things in, you'll always see that we're thinking about the shape. I want to get this shape, therefore I'm just going to get the sine node. Once you see it used in practice and try it a bit yourself, you will find that it does become more intuitive. And you can start to use it a little bit like you would a brush, a potato stamp or similar. So there we have it. That is pretty much the basic overview of what I suppose I would call my art theory, for want of a better term. And maybe some of you like it, maybe some of you think it's a bit wishy-washy. Certainly I don't expect that it's the answer or panacea for everybody's problems with the node editor, with regard to these more technical features and approaches. But this much I am certain of. If you go through these tutorials, keeping this approach in mind and seeing how I demonstrate its use in grabbing certain nodes to do certain jobs, that everyone will see at least a little bit of something in what I'm trying to get at here. And I am also certain that therefore everyone can find something that is going to help them improve their abilities when working within the node editor. And so with that, we'll draw this little guy to a close and move on to other videos that demonstrate the technique and ideas in practice, and also go on to discuss and describe other features or nodes or types of data that we're going to play around with that need just a little bit of a technical understanding or view of the concept.